Struggling with shear force diagrams? Let's simplify it together. In this video, I will show you how to draw accurate shear force diagrams for beams using step-by-step process. Learn how to quickly draw these diagrams using sign conventions, reaction forces, and how to handle uniformly distributed load. If you follow these steps, you will be quickly and confidently able to draw shear force diagrams for simple beams at least. By the way, if you're new here, I'm Dr. Jawed Qureshi, a senior lecturer at University of East London. In here, we talk about structural engineering. This is part of my video series on IStructE certificate in structural behavior, or simply if you want to improve your basics of structural engineering, this video is for you. In this question, we have to identify the correct shear force diagram, ignoring self-weight. Anti-clockwise shear forces are drawn positive. This is a sign convention, and this is how I'm going to draw this shear force diagram. Upward forces are positive and downward forces negative. Here, the reaction is going to be upwards, and the force applied is downwards, but this will be a line, and this is creating a clockwise moment. So clockwise moment is drawn on the negative side. This means that the diagram will simply look like this. So this is the shear force diagram for a cantilever with uniformly distributed load. Option B is incorrect. Option D is incorrect as well. And this is for simply supported beam. This is incorrect as well. So the correct option is option A. In this question, we have to identify correct shear force diagram, ignoring self-weight. Anti-clockwise forces are positive. This is the sign convention where anti-clockwise forces are drawn positive. And this is how I'm going to draw SFD, or shear force diagram. Let us see what options do we have. We have a couple of options and we can discard some of them, but it's difficult to say which one is correct. Let's make some assumption. Assume point loads to be equal. I will say it's 10 kilonewton, and I'm assuming UDL to be 5 kilonewton per meter. And distance here is assumed to be 4 meters, and we have 4 meters as well. We have UDL. The total reaction here, these two forces, they will cancel each other. So total reaction over here will be upward reaction. UDL is 5 times 4, 20, so the reaction will be 20 kilonewton. I'm now in a position to draw the shear force diagram. So this force is downwards, and this is causing a clockwise moment. So I will bring it down, and this is 10, and then it will go up due to this force. And at this point, I have a uniformly distributed load starting from here. Now I'm at a position where I have 0 force, and then I will subtract 20 from here. So when you subtract 20, you reach at this point, and finally you have a reaction over here. This entire bit is negative. So the correct answer is option C. All other options are incorrect. You saw that by assuming some values, we are able to plot this really very quickly, and it makes our mind map really very clear when we have some values. Without values, it's difficult to say which is the correct one. But here you can fairly assume that these two forces are equal, so that's why they will cancel each other. Then all you have to do is to draw a diagram from here to here. As 2 point loads are equal, so the force goes 0 at midpoint, which is here. So that's why we have this option as correct one. Identify the correct shear force diagram for this question. Ignore self-weight, and anti-clockwise shear forces are drawn as positive. This is the sign convention which I will use. And this is how I will draw the shear force diagram. I have a couple of options over here, but I will draw the deflected shape, and that will really give me the idea which diagram is correct one. In this question, the first thing I will do, I will plot the deflected shape. So if you plot deflected shape, it will be like this. But if I separate this portion, no load is being applied. This means that I can reduce this to this diagram, and only loading is applied over here. Now it's very clear for me how to draw the diagram. So again, I have 0 over here. As it is not restricting, the pin is not restricting it, so the reaction over here, it's going to be 0. The only reaction here will be upward reaction at fixed support, which means that there aren't any forces anywhere else. So when there are no forces anywhere else, then the diagram is going to be drawn at just that portion, and this is creating anti-clockwise moment. So anti-clockwise moment is drawn positive. The way I will draw it is like this. So anti-clockwise moment is drawn positive, and over here all other forces beyond this point, they have nothing to do because these forces are not developing. This means that the correct option is option C. All other options are incorrect. In this question, we have to draw the correct shear force diagram. Ignore self-weight and anti-clockwise shear forces are drawn as positive. This is a sign convention which I will use here. And this is how I will draw SFT. This is a very simple question where we have a uniformly distributed load and a point load being applied. Option B is incorrect because it's not possible for UDL to go in downward direction. We have a reaction over here as well. There are two reactions here. The reactions will take the diagram upwards, and this is not possible as well. This looks like more a BMD, bending moment diagram, rather a shear force diagram. Now there is a possibility of these two options, and I think option D is correct because we have a reaction over here and we have reaction over here, and then we have a UDL, and when we have a downward force. So reaction at right side will move the diagram upwards, and UDL, for UDL I will subtract value up to the half point, and this point load will bring it down, and then again I will subtract value of UDL, and this point load will bring it up. In this way, the correct option is option D. This was the most simple one so far. Let's move to the next one. We have to identify the correct shear force diagram. Ignoring self-weight, anti-clockwise shear forces are drawn as positive, and this is the sign convention which I will use here. And this is how I will draw the shear force diagram. So let us see what options do we have. We have a point load at the end, and we have uniformly distributed load. It means it will do something. The point load will bring it down, and this UDL will bring it down as well. So here nothing is coming down, so option A is incorrect one. And option C is incorrect as well because here rather it is going up, which is incorrect. And option D is showing a curved pattern. Curved pattern is related to bending moment diagram rather than shear force diagram, so this is incorrect as well. And option B seems correct because we have a UDL over here and we have a point load. So point load is bringing it down. Because of UDL, it is inclined portion, and between this portion and at the end we have nothing. Reaction is upwards, and this remains a straight line. It means that the correct option is option B.